Hi, I'm Stefano.
I'm Max.
And I'm Eric, and this is our senior project.
We are working with Crystal Engineering, part of Amitech, which is based in San Luis Obispo. They develop, manufacture, and distribute products used to measure pressure, calibrate equipment sensors, and diagnose the performance of equipment. They currently operate 7 product lines at their facility from which they generate revenue. Crystal Engineering is currently in the process of introducing 3 new products, 1 now and 2 within the next 6 months. However, their existing lines already occupy the available production space, and as a result, they are unable to determine how to effectively incorporate new production lines within the facility. The high-level objectives for this project are outlined as follows. We will provide an in-depth analysis of the current facility layout that will involve understanding the processes for each product line. After gathering an understanding of the production strategies and processes, we will provide several facility redesign layouts that incorporate engineering tools and principles.
For our project, we have identified several constraints that were given to us by our clients. These constraints include not being able to purchase another facility, as that is out of the scope of this project, and also not being able to relocate 2 areas due to excessive costs and safety concerns due to excessive noise.
The first design approach we chose was the systematic approach to facilities design. This process involves several steps which incorporate the systematic layout planning process. The most important step in beginning a facilities design project is understanding the operations. This involves all of the processes and flows of material and people that occur on a daily basis in the facility in order for it to run smoothly. To define operations, we use flowcharts to map out the processes for each product line. Here is an example for their M1 product line. As you can see, we color-coded the flowchart to indicate the type of workers that are associated with each step. The flow process diagram on the right includes the distances and the type of step, be it operation or inspection. The spaghetti diagram shown was made in Visio in order to get the distances for each of the steps. All of these tools were used to map out all products.
We then defined the different departments within the facility and the square footage required by each of the departments based on their needs. The From To chart demonstrates the number of trips per year made between each area. From this table, we can see that from assembly to the conversion table is 293 trips per year. The relationship diagram as seen on the left ranks the importance of different departments being located in close proximity of one another. From this, we get the space relationship diagram as seen on the right. Each department is depicted in its actual size, then lines are drawn between departments, indicating a visual representation of the importance of the departments being located next to each other. Another design strategy that we also looked at was cellular manufacturing. The holistic goals of this method are to accelerate production as much as possible, manufacture a wide variety of similar products in close proximity while minimizing waste. The approach we took for this method is outlined as shown. After documenting process flows for each individual product, we broke down each process group into departments. We then calculated similar product groups using a cellular manufacturing matrix. The cellular manufacturing matrix shows the broken down processes on the leftmost rows, and the product lines are shown in the top columns. The marked X's signify the products that utilize the corresponding process step. Our goal was to cluster it together as many similar marks as possible to define similar product groups. We identified 4 group cells that were placed as close as possible into the facility redesign, while taking into consideration the client's requirements and constraints. This slide shows the facility layout of the current state. The entire facility owned by Crystal is in 3 separate rooms, with 1 room being detached from the other 2. The slide shows the areas of our project scope, which can be broken down into 4 specific areas: the main production floor, auxiliary floor, administration, and warehouse. For our redesigns, we will only be moving objects within the 4 boxes due to project constraints. Our first facility redesign incorporates our cellular manufacturing method. It can be noted that 4 cells identified in the cell matrix were grouped together as close as possible. Areas such as inspection, finished goods storage, and shipping were not taken into consideration since all product lines utilize these processes. It can also be noted that areas such as pre-welding as well as conversion and kitting tables are placed in between certain cells since they are both utilized by them. This design features 3 group cells in the main production floor and 1 in the auxiliary floor.
This design was based on the SLP process and space relationship diagram. This layout moves the majority of the assembly operations and the welding area to unit number 9, on the top portion of the facility. This therefore opens up space in unit number 11 for possible future expansion. Another major change from the current state is the consolidated area for the engineering department's storage and testing equipment. This design was also based on the SLP process, yet there is more subdivision of the assembly department throughout the facility. The SPT and DCT product lines and the calibration chambers for those remain in the same area, on the bottom left of Unit 11. There is also more space in the warehouse for more inventory storage. Another important change on the 2 SLP layouts was the moving of production planning department and customer service repairs area into the office space. Since there was no significant relationships for these departments, they could be moved outside of the main production floor.
This layout was created to showcase maximum space savings, as it was highly stressed by the client that their main concern was not enough available space for their increasing number of product lines. The main focus being to free up the production floor through the following changes: giving engineering a dedicated workshop in the warehouse, and moving administrative tasks such as production scheduling and customer service into the office area.
We used analytical hierarchy process to determine the optimal layout because we wanted the voice of the customer to weigh the importance of different factors. The factors were determined by conversations with the customer. The customer used the scale on the right to compare each factor, which allowed us to calculate the weights. After evaluating the layouts based on each of the factors, the resulting matrix on the left was multiplied by the weight of the factors on the right to determine the optimal layout. The resulting weights for the alternatives are below.
After using analytical hierarchy process to determine the optimal layout, our highest score came from design number 3. This design incorporates the systematic layout planning method. From this design, it can be noted that significant space has been opened up in the warehouse as well as some space in the main production floor.
The total cost of implementing this layout is $2,579. The annual savings for the reduction in the amount of distance traveled is $181.20. Now, the potential increased annual revenue is $2.9 million, and this is based on the amount of space we made available for future production.
To recap, our senior project incorporated the following tools. SLP was used to define relationships and space relationship diagrams to develop alternative layouts. Spaghetti diagrams were used to outline the flow of products throughout the facility. Process flowcharts were used to delineate the process for each individual product. AHP was used to make decisions by creating categories of importance, giving them weights and then ratings to see how they justify each category. Project management was used in the overall management of the project. Tools such as the Gantt chart were used to effectively organize the project and break down the work needed to complete it.
For ethical impacts, some layouts may put workers in less desirable work areas for the sake of efficiency. For societal impacts, our layouts will allow for the company to bring in additional product lines, which will open up the opportunity for employment to the inhabitants of SLO. For organizational impacts, before open spaces were often taken over for use by various parties. In these layouts, it is paramount that the uses of space be strictly regulated, changing the culture. For environmental impacts, each layout throws away a lot of unused equipment and materials such as old advertising, computers, and chairs. This has an environmental impact of increasing the amount of material in landfills.
Thank you for taking the time to listen to our senior project design process. Please let us know if you have any questions or any constructive feedback you may have. Thank you and goodbye.